This morning's engagement, as has been titled, Integrating Energy Efficiency Requirements into the Building Permitting Process. And I believe we have some people online and with us in this room. We're going to have some opportunity to discuss this topic. For us at the institution, this is a very important topic. And essentially, it also underlines our continuing engagement with the Energy Commission. We have a relationship with them in that we have been having much collaboration on the issue of energy auditing, which has a standing MOU that backs our activities. And I think we probably had about 3 or 4 inductions so far. There are some outstanding that we'll have to do. And there are even some papers that we still have to review and to certify. So it is an ongoing engagement that we have with them. And there are several avenues to improve on that engagement. And I believe that this offers a great opportunity for us to see how best we can consolidate that engagement. So we will not do much talking. There's a presentation that they would do for us. And then when they finish, we would have the opportunity to ask questions on that. So we would invite Engineer John Adjei to come and give the introductory remarks.
Thank you, Chairman. Engineer too happens to be my chairman, so I have to be steady. Other than that, he can double me, as they say in the military. Okay, so I'll just give some opening remarks, and then my colleague Ebenezer Chair will take us through our presentation for today. The Director of, I nearly said Medical Services, DMS there, Membership Services, the Chair of the Electrical Division, all protocol observed. It is both a privilege and a profound responsibility to stand before us today. Today, we are not here to present a finished regulatory framework. We are here to begin a partnership between the Energy Commission and the Ghana Institution of Engineering, the MMDAs, and all stakeholders in Ghana's built environment. A partnership whose purpose is simple but transformative, to ensure that every new building in Ghana is designed to use less energy, cost less to operate, and serve its occupants. It serves its occupants better for generations to come. Ghana is building faster than at any time in our history. New homes, new schools, new hospitals, new factories, new office towers, new shopping centers. Every day, thousands of square meters of new floor space are added to our cities and towns. This is progress, and it is cause for celebration. But it also raises a question that sits at the heart of our professional responsibility. What kind of Ghana are we building, and for how long will it last? Every design decision we make locks in energy demand, operating costs, and carbon emissions for generations yet unborn. If we get the design wrong today, we will pay for that mistake every single day throughout the life of that building. Historically, we reinforce the distribution network. That model has served Ghana well, and it will continue to play an important role. But the reality is changing. Building additional generation alone is becoming increasingly expensive. It requires enormous capital investment. It requires enormous capital investment. It takes years to complete. It increases pressure on fuel imports and foreign exchange. And if our buildings continue wasting energy, we will always be chasing demand rather than managing it. The evidence is clear. Buildings already account for a substantial and growing share of Ghana's electricity consumption. Inefficient design, poor orientation, inadequate shading, and oversized mechanical systems mean that a significant portion of that energy is simply wasted. The result is higher bills for families and businesses, greater pressure on the national grid, increased fuel imports, and a heavier burden on our climate commitments. Ladies and gentlemen, around the world, the role of buildings is changing dramatically. Buildings are no longer viewed merely as places where people live and work. They are becoming active participants in the energy system. A modern building can generate electricity through rooftop solar, store electricity in batteries, manage electricity through smart controls, share electricity with the grid, support grid stability through demand response, charge electric vehicles, respond intelligently to changing energy conditions, and so forth. In other words, the building itself becomes part of the national energy infrastructure. This is the future towards which the world is moving. And Ghana has an opportunity to move with it. But there is one foundation upon which all of these technologies depend. That foundation is energy efficiency. This is precisely why today's consultation is so important. Engineers occupy a unique position in the building delivery process. Whether you are a structural engineer, electrical engineer, mechanical engineer, civil engineer, energy engineer, or consulting engineer, your decisions determine how efficiently a building performs over its entire life cycle. Energy efficiency is no longer solely an architectural consideration. It is an engineering responsibility. The performance of HVAC systems, electrical distribution, lighting systems, building controls, water pumping, renewable integration, energy modeling, commissioning, monitoring, all depend on engineering excellence. When orientation is poor, you are asked to compensate with larger cooling systems. When the envelope is weak, you are asked to make up the difference with more energy. Mr. President, you are welcome, and thank you for honoring us with your presence. When the envelope is weak, you are asked to make up with the difference with more energy. When construction quality slips, the performance gap becomes permanent. Your expertise is essential if Ghana is to successfully implement the Ghana Building Code, the building regulations, and so forth. The forthcoming energy performance certificate regime, which we are going to share here, will depend on how we engineers help it to work. Either way you look at it, a building does not just come up. It involves a whole lot of people, and engineers play a very key role. So we do not consider this engagement lightly at all. We don't take it lightly. You are the brains behind buildings that are coming up in Ghana. Today's consultation is not about presenting a finished product. It is about co-creating a system that works. We want your professional advice, your practical experience, your technical concerns, and most importantly, your recommendations. The Energy Commission cannot achieve this alone. Neither can the Ghana Institution of Engineering, neither can the architects or the MMDAs. Success depends on collaboration. The government, professional institutions, universities, developers, contractors, engineers, architects, surveyors, building inspectors, energy assessors, and every stakeholder has a role to play. When we work together, we do not simply improve compliance, we improve the quality of buildings. We reduce energy costs. We strengthen national energy security. We improve comfort and productivity. We create better cities. And we leave a more sustainable Ghana for future generations. Our vision is simple. A Ghana where every new building uses less energy, provides comfort, costs less to operate, support the electricity grid, embraces renewable energy, and contributes to national development rather than increasing national energy demand. That vision is achievable, but only if we design it for today. Only if we design it today. Ladies and gentlemen, the decision we make today will shape the buildings that future generations inherit. This consultation is therefore not merely about compliance. It is about leadership, innovation, engineering excellence, and all these things. And above all, it is about building a Ghana that is more resilient, more competitive, and more sustainable. I encourage all of us to participate openly. Let's share experiences. Let's challenge some of the assumptions. And let's offer practical solutions. Together, let us design not only better buildings, but a better energy future for Ghana. On behalf of the Energy Commission, I thank the Ghana Institution of Engineering for hosting this engagement. And I thank all of you for taking the time to contribute your expertise to this important national initiative. I wish us all fruitful deliberations, and thank you very much. So, here to take advice. We are here for your recommendations. We are here for you to critique some of the assumptions we have made in the draft. And we believe that by the time we are done with this consultation, the document will become richer and not poorer. All right. So I know the IT the IT team is putting the presentation together, and so once they are done, I'll leave the stage for my colleague Ebenezer Tre to take us through. So that is it for now. All right. So what do we want to see? When we are living here, we want to see, or we want to go with some suggestions or some input from the Ghana Institution of Engineering. If they are not readily available, we will leave our contacts behind. Or better still, I'm one of you. So you can just reach out to me. That's what you came to present. We have seen that there are holes here. Block this hole. We have seen that this beam is too thin. Make it 20 inches instead of 15 inches. Collapse this particular, all these things, and we use our technical jargons and all that. So that is what we want to see. We don't want to live here with the document intact. We want you to chisel, break through, cut, and so that by the time we leave here, we know that we have gone through a surgical operation and we are much healthier. All right. So all right. So we'll take the opportunity to introduce ourselves so that I know almost everyone here, but my team, they don't. So just for emphasis, my name is John Ejay. I'm a member of the Electrical Division. I'm part of the executives. Engineer Ebenezer Roberts is my chairman. All right. So I'll go over to my team. They will also introduce themselves, and then the host will also introduce them, and then we can go into the presentation.
Good morning. I'm Ebenezer Ashi from the Renewable Energy and Energy Efficiency Unit, Energy Commission.
Please, I'm Samiha Suleiman, Energy Commission. Okay, and the Public Affairs Unit.
Good morning, everyone. I'm Boatsma Answer with the Energy Efficiency Regulatory Unit. Thank you.
I'm Jesse Bunudua, Energy Efficiency.
My name is Gertrude Iramonkuma, Energy Efficiency.
I'm Samuel from Public Affairs Energy Commission.
Eric Coleman, Energy Efficiency Regulation.
The last member, he will do the representation, so he will introduce himself.
Please let me hand it to our Acting Executive Director.
Good morning to you all. Let me take the opportunity to introduce some of our officials here. I start with Engineer Atu Roberts, is the chairman of the Electronic Technical Division. We also have Engineer Juliet Gometa. She's the Director Membership Services. I should have started with the President. Pardon me, Mr. President. Engineer Ludwig Annan Hesse is the President of the Ghana Institution of Engineering. We also have Mr. Odenke Abbey, Publications, Communication and PR Manager. Who else is here? The rest of the team here are our team members from the Secretariat of the Ghana Institution of Engineering. My name is Aisha Usmano. I'm the administrative manager here. Yes, thank you very much for the opportunity.
So I can see that they are tweaking a few things to make the presentation ready for us. So please bear with us. We'll take off very, very soon. And we don't expect this engagement to go beyond 1:30 or 2. Yes, it's a pretty straightforward presentation. In between, yes, we have a snack break. And then when we are done, I think it will be it's better okay, all right. Okay, so yeah, in a nutshell, that is what we want to do today. Okay, so online, very good. We have 53 participants, 54 rather. Very, very good. Okay. Can we hear from online? Can you give us a hi?
Hi.
Hi.
Okay. I can see we are heavily represented. Yeah, it's a shame the lunch and the snack break, we can't do the e-version, but we are happy to have you. All right, so Eben, if you are ready, please take us through. If they can help us, if they can control it for us.
Okay.
Can you mute yourself for us? Online, please mute your microphones for us. Thank you. So we are sorting out a few things with the presentation. Our pointer is giving us a few problems. And so we are sorting it out. We'll be taking off very, very soon. Online, please bear with us. Okay, so I have a suggestion. Eben, why don't you start? Okay, let them change it for you manually while we sort out the pointer issue, so that we don't waste too much time. Let them change it for you manually. We can sort it out behind the scenes and then give you the pointer later.
Okay, we are just about starting. We wanted to acknowledge members online, 61 of you. Alex Emmanuel, Abraham Bafo, Akosia, Jamina, Mercy Frempong, Dr. Mary Aintree, George Kafui, Foley, Gloria, Engineer Emmanuel Donko, Engineer Daniel Idani Ali, Jemima Israel, Josephine Awude. I'm just scrolling through. Nehemiah, Nick, Prince, One Plus, Rosling Awachiprat, Steph, Tahiru, Yusuf. Thank you all for joining. A few housekeeping rules. Kindly be muted. If you have any comments, please put it in the chat box until
Hello.
the share so that they can join. Thank you.
Starting with my last slide. Engineers, your microphone is very heavy. I don't know whether it's a specialized engineer microphone. Okay, so Ebenezer Chere and I work with the Energy Commission. And normally when I ask people their name, I expect to hear the other names. You know, when we went to school, you mention your name, they will ask you, what's your guy name? Because it's the guy name that let us know the real person you are. If I mention Ebenezer Chere, you don't have anything. You don't have any clue about me. But if I mention the other name, you will have some clues. So during the introduction, if I was the one that handled it, I would have asked for the guy name. Okay, so I will start with the presentation. I won't mention my guy name. Maybe at the end of the presentation, I'll add that. So normally when you're meeting engineers, you're expected to talk about kilowatts, megawatts, the terabyte, and the other things. But before we talk about anything of that sort, I want to ask one simple question. And the question is, what is humanity's greatest invention? We are engineers. What is the greatest thing that we've engineered as engineers? Any clue? People say it's the wheel that changed transportation. Others say it's the fire. People say it's the flights. Others say it's computer, electricity, AI, phones, and other things. But I want you to think very basic, away from the machines and the tools. What is our greatest invention? Any idea? Or I should proceed? Okay. Electricity. Okay. So all these are very important, but before the electricity, before we split an atom as engineers, before we went to the space, our grandfathers, they needed a shelter. So they built a shelter for themselves. The shelter became a home. It became a community with time. It became a town, a village before town, and then a city. And cities are the basic of civilization. So buildings remains our greatest invention, despite all the other things. So the answer is buildings, and that's a platform on which every other invention is created. You need a good place to sit, to even have the mind to think about that great invention. So buildings are more than the walls that we see, the roof, the floors, and the other things. They are the places where humanity's life is shaped. Buildings are where we are born. Buildings are where we learn. Buildings are the secret witnesses to our prayers. You know, we went to a closet and we whisper our prayers, but the buildings hears us. So buildings are where we learn as students. Buildings are where we stay as a family. They are the offices that we create wealth. So buildings are also our greatest investment. And that's where wealth is created. I think my slides are jumping. Okay, so every great buildings deliver the global agenda because any of the greatest or any of the agendas, water, energy, they are all connected to buildings. Buildings are at the center of them. So any country who is serious about meeting the global agendas cannot take a step leaving buildings behind. Buildings define nations. The story of every building is told by the structures that they have. When you see the pyramids, you see Egypt. When you see the museums, when you see the cathedrals, you see Europe and other things. You see Dubai with these tall structures. And I had a friend who worked in Dubai, and he's always very interested in cement. He said one thing that cement has helped us achieve is to build tall structures. That's what cement has helped us achieve. But the question I asked today is, what structures define us as Ghanaians? Is it going to be the Ghana we knew, the Ghana of old? Is it going to be the Atakwa Medan that was built by our great-grandfathers that were designed to work with nature, built with our local materials? And normally I say our forefathers, they didn't study engineering, they didn't study science, but they understood the direction of the path, the direction of the wind. And even before science, they designed or they built buildings that were thermally comfortable before air conditioners. But today we are doing different. So which buildings will define us? The buildings that observe the natural ventilation, solar orientation, thermal mass, or is going to be a different structure? The buildings that were designed to breathe, or is it the Ghana that we are building? The Ghana of imported materials, imported designs from other climates, materials designed to solve problems in other regions. We import them and we start facing them here. And we are designing, not respecting our climate. So at the end of the day, instead of, if the light goes off, you just have to on a generator because you can't stay comfortable in a space. So now we are building the Ghana of glass facade, the Ghana where we clear every tree, every forest, then we replace them with concrete and other things. And when the sun shines, the heat is not absorbed. It radiates and is creating urban heat island. And according to research, Accra is 4 degrees hotter than the surrounding towns, the Dodowa and the Bri. Why? Because the heat are not absorbed. The cement with we have what we call night ventilation. I can't open my window in the daytime because of dust, but at night I open for the air to come in because movement of vehicle has ceased. But because of urban heat island, the nights are even becoming warmer than the daytime. So which Ghana are we building? It is the Ghana that is fighting the climate every hour of the day with generators and other mechanical systems. or the Ghana that is fulfilling this prophecy. And I want us to read this together. In fact, it's my favorite. This is my favorite by Russell Ackoff. And it says, we fail more often because we solve the wrong problem than because we get the wrong solution to the right problem. We are failing as a country, not because we are getting the solutions wrong, but because even our questions, we've not understood it. Our problems are not well understood. So how do you start to solve the question that you don't understand? And that's the problem that we are facing as a country. When you ask a Ghanaian a question, they are always rushing with answers. You don't seek to think, to even get the rebound effects of the solution that we are proposing. What is the side effect of the solution that you are proposing? Because sometimes the side effect of the solution can be more than the problem you are trying to solve. So we are always having quick fixes, not thinking deep into our problems to get the right solutions. And I'm talking about imported designs, imported materials, not because I'm against them, but I'm calling for a blend. We shouldn't deviate from our traditional wisdom. Now we are innovating. That's why we have these materials. And there's no room, when it comes to innovation, there's no room for try and error. You have to get it right. So you should innovate, you should move ahead, but you should also remember our science. And our traditional buildings, now we demand more from our buildings. Those buildings were just for shelter. Now we want thermal comfort in our buildings. You want durability, you want indoor air quality, you want low operating costs. We met the greater people and I was telling them, those days people want 5 bedrooms. We were looking for the sizes. We were buying number of rooms, 3 bedrooms and other things. Now people are not looking for number of rooms. They are looking for operational cost. How to be the cost of the operation of me buying that property. So the real estate sector is changing. We have more demands for our building. We want buildings to be energy efficient, climate resilient, and other things. And our traditional building, which was based on past presidents, successful past presidents, this person did it this way, it was successful, so this person also repeats it. And that's how we were building. But now it's changing. We are being innovative, and we are just copying and pasting. We are not testing anything. We are just assuming, not modeling to know the performance. We are not verifying anything, and that's not helping. So we need a blend. We need our traditional wisdom. We need our modern innovation. Then we need our building science to get the performance that we request from our buildings. Normally, when we say building failure, as a Ghanaian, the only thing that comes in mind is building collapse. That's the only thing that we see as building failure. And that's why there's so much emphasis on structural integrity. But if the building fails to meet any of its performance parameters, the building has failed. If the electricity goes off, then visually you can't see anything in the room. You can't stay in the room. Then the building is failed, because at least you have to have some passive way of surviving in that structure. So we need a blend, and this is an office space at the Energy Commission. We call it nearly zero energy building. And this is an example. It combines the traditional wisdom. You have the passive strategies. You can see the shading devices. That's providing a second layer to the main wall, shading the main wall from direct sun rays. And we have other mechanical systems. In case the passive strategies are not enough, we have the mechanical systems to support. And normally when you consider the passive system first, it even reduces the size of the mechanical system. In case you have to buy 2 horsepower, with the passive, maybe you don't need a 2 horsepower air conditioning. You might need 1 horsepower. So, and local materials were prioritized. Normally, my devotion this morning, there was a statement that said every material must be connected, or system must be connected to a source. So it's talking about us as maybe children of God. So the word of God is our source. So the building materials, our local materials, they are drawn from the same environment, and they function well in this environment because they know how to handle the sun radiation. They have high thermal mass properties, our clay and the others. They have high thermal properties, delay the conduction of heat into the room, maintaining the internal environment for us. So you should innovate with science. Then the Ghana we must build must consider the climate and also the modern technology. Once again, which buildings will define us? And I'm concerned because unlike appliances, unlike cars, unlike even the thermal power plants, which needs maybe after 30 years, you have to maintain, buildings will last for not less than 50 years. The lifespan of a building is 50 to 100 years. So every decision that you are taking about the building, though at the design stage, but you should know that that's a long-term decision that you are taking. And if inefficiencies are built into the building, you know that the inefficiencies will stay for 50 years, at least 50 years. So every drawing engineer today will permanently lock in energy demand. You lock in operating costs, property value, carbon emission, not just for tomorrow, but for 50 years. So after your construction, you lock in orientation. You can't change the orientation of your building. After you've cast your concrete and those things, you can't change the orientation. You can't change the roof design. You can't change the window size and placement. And now you have renovation. You can do the renovation, but sometimes the renovation can even cost more than, if you're doing a total retrofit, it can cost more than even building a new structure. So you should have that in mind as we design our buildings. So the real decision every day for a century. In Europe, they are concerned about the performance of a building because if it's in an office building, after constructing that building, that's just one cost. You are going to have people working in the building for more than 50 years. Every month you are going to pay them. So at the end of the day, the money going to paying your workers will be more than even the cost of the building. So is the building in a way, functioning in a way that you are getting the best from your workers? Because if, for example, the office space is not thermally comfortable, you can't get the best. You can't even stay to work to produce the results that has been demanded from you. So they are concerned about building performance. So Ghana is building fast. At first, in the 90s, these were not issues, but now Ghana is building fast. We are experiencing construction boom as a result of our population growth, our urbanization rate, which is increasing rapidly, our economic growth. So you see buildings emerging or cropping up every day. Every day you see someone hitting the ground with a pickers to start a new construction. So we are building more, our buildings are increasing. And the question I ask is, are we building progress or we are building pressure? Because every building is an investment. It stands for progress. It shows that as a country, we are progressing. But it's also pressure if we are not building right. And it's pressure because buildings consume majority of our electricity production. Majority of electricity production goes to the built environment. So if buildings are increasing, as someone who is working at the energy commission or energy sector, I'm concerned because every building becomes an asset to our energy system. And I say it's not just for tomorrow, but at least 50 years, you have to supply that building with energy. And how are we going to do that? So building is driving Ghana's electricity demand, and research continues to show that 30% of the electricity entering a Ghanaian's household is being wasted on inefficient designs, inefficient user behavior, inefficient appliances that we are using in our homes. And normally, I call inefficiency the thief. So if there's no change in the way that we are building and the way that we are using energy in our buildings, what are the consequences? And it's clear there will be a lot of stress on our electricity grid. So Dunso will return, or is there already? But this time, there will be greater intensity You're going to have dunso with greater intensity. The cost of electricity will be higher for parents, for businesses, and also for our nation. And as a country, the country also pays energy bills. Not everybody knows that the country pays energy bills, but the country pays energy bills. We rely on thermal plants, which also relies on crude oil, natural gas, and others. And when our domestic supplies are not enough, we have to import from other countries. And that's a huge money, not less than 1 billion USD in a year. And that represents a lot. There are several kilometers of roads that can be constructed with that money. Not less than 70 hospitals can be built with that money. More than 2,000 classroom blocks can be built with that money to educate our children. But they're all going to importing fuel to feed our generation capacity. So without any intervention, we are even paying the thief. And I say I call energy inefficiency or inefficiency the thief, because that's a thief. It's stealing from the family, because I've seen it before. A mother who has to decide whether to buy prepaid for the children to study or save that money and give it to them tomorrow to buy food. So that's inefficiency, stealing from that family. It's stealing from the businessman whose company is collapsing because of high operating costs due to electricity. Now, electricity is expensive. So the business is collapsing, not because he lacks ideas, but because he can't sustain productivity, high cost of productivity. And also, it's stealing from our government. I told you, money that can go to other sectors, hospital, construction of roads, they are being used to generate energy to feed the waste, to feed 30% waste. And that's bad. So normally when people hear the environmental impacts of the building, they ask a direct question. Does that mean that we should stop building? And we can't stop building. I mentioned earlier, buildings are important because as a country, you are increasing, you are giving birth, we need the homes, the classrooms, the offices. So the question is not to stop building or whether you should stop building or not. But the question is, how do we meet our future energy demand? How are we going to meet our energy demand? And this is a question that we all have to answer as we sit here. So after the presentation, everybody is going to give me the answer that you think, then maybe you know that down. So there are two ways, and as an electrical engineer, this is what I was taught in school. When there's an energy demand, when it increases, what do? We build more power plants. We extend the grid, we extend the distribution lines, then our homes are passively somewhere. We connect it to them to consume. And that is important because any country that's progressing needs a stable electricity to progress. But is that sustainable? Building new thermal plants, you should know that it's a massive investment. It takes a long time. It depends on fuel imports, and we know the consequences that comes with fuel imports. It makes us independent. So when there was a US-Iran war and there was no fuel in the country, we felt the heat. That shows that we are not independent energy-wise. It has higher tariff and also produces emission, pollution. And there's a popular saying, he said, we cannot solve our problems with the same thinking we used when we created it. Today, we are complaining about emissions, pollutions from generational plants. So can we solve that? Can you meet our energy demand, building more thermal plants? We can't do that and come again to complain about emission. So the world is already rethinking energy. We are rethinking the new energy at renewable energies. We are looking at two-way energy trading. That's you are building being a prosumer. So you generate to meet your need, your energy demand. When there's excess, you feed to the grid. We are thinking of active prosumer, resilient distributed network. We are thinking about storage and renewable driven. So this is how the future energy system, and these are what the research or what we are proposing for the future. The rooftop, the batteries, electric vehicles, smart grids, the microgrids, smart meters, AI, and other things. And when you look at all these technologies, all the smart meters, they are connected to buildings. So buildings in the future, buildings are not passive in the energy system, just there to consume energy, but they are active players in the energy system. Because a building can store energy, you can charge your vehicle in a building can generate energy and feed the locality or other buildings. So the future is to make buildings also the solution. Buildings are becoming the heart of the system. So in the future, every rooftop is a potential power plant. Every building is a potential battery. Every development is an energy asset. In the future, buildings become a miniature power plant, on-site battery, flexible grid resources, and a climate solution. So, and as a country, we are positioned to lead when it comes to this, because we have millions of rooftops which can house or support solar panels. You have rapid urbanization, you are building every time. So you have construction boom, digital networks, you have the technologies and the other things. And now we are promoting the electric transportation. So we are in a good place to lead. And this is the past, or this is current, and this is the future that we're proposing. And you can see that there's a huge How do you do that? Any suggestion? We need a quantum leap. Engineer, and how can we jump? And we have to transition. To transition, we need a power plant. We need another power plant that doesn't import or burn fuel to produce gases, emissions. We need a power plant that doesn't produce smoke, that doesn't need transmission lines, that costs a fraction of the thermal plants that we are building, and that can start today. We need a power plant that already exists. And what power plant is that? It doesn't produce smoke. Okay. Oh, okay. I thought you were giving me the answer. Okay. So, and that's the hidden power plant already in our homes. And normally when I say that there's a hidden power plant in our homes, people, so are you sure there's a power plant in my home? Yes, there's a power plant in our homes. There's a power plant in our office. There's a power plant in every classroom. That's the hidden power plant. Other call it missing power plant. And what's that power plant? What do you for? When you for? Okay, so that's what energy efficiency gives us. And that's what energy efficiency gives us. And energy efficiency is the driver of our transitioning. Now, the energy sector, the ministry has changed the name. We've added green transition. But how do we transition to the green? We can transition through energy efficiency. Why? Because without energy efficiency, the solar batteries are expensive. And that's the complaint. Solar is expensive. Clean energy is expensive. Without energy efficiency, it will be expensive. Energy efficiency will reduce the demand and make sure that the battery is affordable. It's more that you can afford. So it's the cheapest energy because we don't use it in the first place to pay for it. It's the fastest because we can even activate energy efficiency right now in this room. We can activate it. Should I give an example? In every space, and it's self-paying. Investment in energy efficiency is not a loss investment. It pays for itself with time. So the cheapest power plant that we can build as a country is the energy we don't have to generate. I mentioned that we waste 30% of energy, electricity in our household. Do we have to generate that 30%? We don't have to generate that 30%. saving that 30% is equally important with no cost than to produce the 30%. So what is energy efficiency? And I'm asking this question not because you don't know what energy efficiency is. You know, and as an electrical engineer, you know, they didn't teach us energy efficiency. They taught us how to produce energy. From school, I was looking where I'm going to work. I'm going to work at VRA, Gridco, ECG. Efficiency is not just about using less energy. And that's why I'm measuring on this point. It's not about using less energy. Energy efficiency is about wasting less. And I will give one simple example. You know, there was a time that we have to replace the onion bulbs, the incandescent light with the CFS. And now we have LEDs. And look at what we are doing with the LEDs. When I go out, I see decoration. I see people decorating with lights. You see the LEDs everywhere. Can you do that with the incandescent lamp? The onion bulb, can you do that decoration? You can't pay for the cost. But now the LED is saving 80% of the consumption of the incandescent lamp. So we are able to do more with the energy that we are saving. So when we are talking about energy efficiency, light is off, they are struggling to read, and because they want to save energy, the light is off. They are feeling thermally uncomfortable in the space because of saving energy. The AC is off. That's not energy efficiency. That's sacrifice. So this is how do you reduce energy efficiency in our buildings? And there's just simple strategies. One, reduce the demand. Why do you reduce the demand? You have the passive strategies. And two, meeting the demand efficiently. So people think energy efficiency is about buying the 5-star, the most efficient products. Energy efficiency doesn't start with products. It starts with design. Your design has to be efficient first. Then you meet the remaining demand with an efficient system. Okay, so energy efficiency starts with better designs, and that's where we are looking at building orientation, natural ventilation, the cross ventilation, solar controls, and other things. And as a country, our main problem is the heat. So if you are building, what you have to deal with is to block the heat. And that's the main strategy. How do you block the heat? The strategies are there. So you block the heat, one, understanding where the heat is coming in. Yesterday, I was telling someone at our office in the Energy Commission, when I move from the second floor to the last floor, I feel the temperature difference. From the first from the roof, from the walls, and the windows. And normally, windows are the weakest link when it comes to our buildings. Normally, we find people using glasses. They are nice, and we also get glasses for our windows. And you have to understand that the classes, they are not the same. They have properties. Maybe you have single grace, some are double grace, triple grace. So it's not every glass that's a glass. You have to get a proper glass. You look at building systems and also building operation, and this is important. And normally, when you buy appliances, it comes with a manual. But when you build our buildings, there are no manuals to it. So sometimes the occupants or the users of the building, they don't know how to operate the systems. And sometimes I visit most efficient buildings, but broad daylight, and we have outside lights on. That's inefficiency. So the operation also matters. You look at the design, you look at the building materials, but you also have to look at how to operate the buildings. If you are not using the light, it has to be off. So efficient buildings are designed by professionals, but it's sustained by people. It's sustained by those using the facility. So Energy Commission is introducing energy efficiency in buildings because that's the way forward. And after Engineer Jay read the opening remarks, I thought, oh, maybe I don't have to even continue with the presentation because he mentioned every key thing. And what do we need to implement energy efficiency in buildings? One, we need a mandate holder, someone with the responsibility to enforce energy efficiency in buildings, to play that leadership role. And that's what Energy Commission, for so long, we were relaxing. We were sitting somewhere, we left the building, we thought, oh, Works and Housing, they are the ones to manage the building. But you should understand that building is made up of space and services. Without the services, the space is dead. Can you live in a space? You just go to your room. If you have space, you just go there and sleep. But now you need the services, you need the light, you need the water, and that's why the other agencies comes in. So we should all be concerned about the built environment. Another thing is the regulation. You need the regulations on energy efficiency to enforce energy efficiency in buildings. So we have the building code, we have the building regulations, and now we are coming up with energy performance certification. So when we started this Energy Commission, we have to wake up from our slumber, from our sleep, because for so long we are comfortable. And we are introducing a new regulation, energy performance regulation. We will talk about it in details, and that's the reason why we are here. So that's the regulation side, and also an enforcement. Normally they say Ghana is nice in books. We have all the laws, but our enforcement is the problem. So we are connecting the enforcement to the AMDAs, the districts. They are already enforcing building standards, setbacks, fire, environmental impact assessment, and other things. So we don't have to create a parallel system, but just adding energy efficiency to what they are doing already. They are in every district, and they are the gateway to development. Energy Commission is not everywhere. We are only in Accra and few parts in Ghana, but the districts are everywhere. So we want to use them, leverage them to enforce energy efficiency in buildings. Another thing is the support system, that's the investment. And normally I say that as a country, we are not willing to invest in something that will lead to the progress of this country. We are interested in winning elections, but something that will benefit the country, we are not interested. We wanted to start energy efficiency in buildings. They said, oh, we don't have enough budget. Seek for donor sponsor, and that took 3 years. There's not a sign of a country that's serious. Something that will benefit your energy system. Go and seek donor support. And normally when they come, they also have their interest. So change this, change that to suit their interest. So we have the regulatory framework, and I mentioned energy performance certification, which is coming up. Then energy performance certification regulation. Now we are looking at designing, construction, and certification of buildings. And also we are looking at how to make the operational efficiency. So what is energy performance certification? In case someone is asking. This is a certificate that you need for your buildings. So energy performance certification, we are certifying buildings at 3 stages. You have a life cycle of a building. So at the design stage, then as built, then at the operational stage. So before you get a permit to start your construction, you are saying that you need a certificate on the energy performance of the building. You want to know that your building is energy efficient. And normally in Ghana, I say, oh, Ghana, they are for. In other countries, when you are designing your building, you even have to think of how do I supply this building with the energy. But Ghana, be connected to the grid electricity. When I'm designing energy systems for other countries, you think of how am I going to power this building? So even if you have the grid in mind, you arrange for a backup, you plan for a backup for that. And that's why their lights never go off. We just depend on the grid, and that's all. So you need design, and as part of the building permit, so just as you submit other documentation to the assemblies, so in that submission, you need a certificate from Energy Commission, Energy Performance Certification, or provisional EPC to certify your buildings. And normally the design promises a lot of things. You promise triple grace and other things, ceiling and those things. But normally when you go to the field, you find a different thing. So after construction, we also come in with what we call as built EPC, Energy Performance Certification. What was endorsed for you is that what is reflecting on the ground before you get your occupancy certificate. So the assemblies, they have occupancy or habitation certificate. So we are tying that to that as well. And 2 years after operating your buildings, now you have real data, energy consumption data. So we come in with the operational EPC to check, is the building efficient as designed? And that's that. And you can renew it. We are yet to decide on that, either 5 years or 10 years. And that decision will come from you. So we have 3 compliance pathways. How do we meet the energy efficiency requirements? There are 3 ways to do that. We have prescriptive, which is checklist based, and that's only for residential buildings. In most countries, considering EPC, they normally consider the commercial buildings, the public buildings. Place for them, just meet few requirements, orientation, window to size, window to wall ratio, just few parameters. What are the measures that we are putting in place to reduce urban heat island? Do you have greenery in your environment or in your compound? Those are few parameters that we look at for the residential buildings. And for any other buildings, you either choose performance-based or green certification. Performance-based is where you model your building, you simulate it, then you compare it to a standard building to know the energy consumption and check whether it has passed or failed. We are talking about energy efficiency, but others want to even go beyond that and say, oh, I want to consider water efficiency. I want to consider waste management and the other parameters, indoor air quality and other parameters. Destination to have an efficient building for Ghana. And I mentioned that we are integrating it into the building permitting system, and this is important because of early interventions. It's easy to make corrections on the drawing board than for you to start construction and I come and say that break this side. And you can't have this wide window on the west of the building. That's expensive. So on the paper, there's early interventions and it comes with no cost. What will you cost? It won't cost you anything to change the size of a window on the paper. So that's least cost. And also universal coverage. I mentioned that the assemblies are everywhere and everyone who is building will need a development permit. So once you're collaborating with them, we have that coverage, universal coverage, fair competition. Every building will need a permit. You have to meet equal requirements. So that's equal playing field for everyone. So the permit stage is the only point that reaches every building. And normally we say that's the gateway. So we are collaborating with the local assemblies. We've gone around and we've involved the physical planning officers and the waste department officers of every district, all the 262 districts. We've talked to them, we've said the idea to them, and they also bought into it. So now they are ready to enforce, but as professional bodies, normally we also have a role to play, and that's why we are here. We've met grader, we've met the architects, and we are meeting the engineers because of the key role that you also have to play in the building. So this is the flow, design submission. You have the energy performance certification in there. Then at review, they will review the energy performance requirements before they give the permit. At construction stage, they go for construction inspection. So now they don't have to do separate inspection for energy efficiency. When they go to check for other things, as part of it, they check for energy efficiency requirements. Then when the building is complete, as built EPC will also comes in. So these are our major stakeholders, Office of the Head of the Local Government Services, because they handle the district assemblies. We have LUSPA, the engineers also, we are in there, and GIE, Ghana Institute of Architect Engineering, you are key members, because normally we say that the architect will design the space, but you engineers, you design the life of the building. They are designing the space, but you are giving life to that design. So engineering is civilization made functional. You are the one making that functional, and you determine the safety of the systems, you determine the energy consumption, you determine the comfort, the indoor air quality, the lighting performance, the electrical system, the water system, and other things. So now energy efficiency is engineering responsibility. Engineer Jay mentioned that. So energy efficiency is not left for the architects alone. Now, you should know that as an engineer, that's part of your professional responsibility, because 40% of the energy that will be consumed in the building will depend on the engineering design that you do. The architect will take 40, he will take 40, then the operational stage will take 20. So 80% of the energy that will be consumed in the building is determined at the design stage. So what engineers are responsible for: system functionality, energy efficiency, thermal comfort, indoor air quality, and it's not optional, it's your responsibility. Energy efficiency as infrastructure, energy infrastructure. Normally, when we are talking about the building systems, they are not just equipment. You should see them as energy infrastructure. So these are all your work: sizing, having the right size of the mechanical system. And normally, I'm concerned about how we size, especially our HVAC systems. When you see a space, we think, oh, this space maybe 2 horsepower. And we go and buy 2 horsepower air conditioning to fit in the place. Meanwhile, we don't even do load. What is the energy demand or the cooling load of the space? We don't do that. And we just use our eyes to size. But you have to use our pen. You have to do the calculation to size. So, so the electrical systems, you do that. And for electrical systems, I went to Tamale and I slept in a hotel. So when I was going to bed, I went after shower, so I off the bathroom light. So I was like, she came and said, oh, you've off the outdoor light. And I just off my bedroom, my bathroom light. How is that connected to an outdoor light? And you can see that is a work done by someone who is not professional, a family member. Light, but it has to stay on throughout the night to waste energy. You design the water systems, the lighting systems, and normally it's not for decoration, they are for purpose. So don't design lighting systems for decoration. The building envelope interface, you have to understand building fixes: conduction of heat, conversion of heat, radiation. And normally every office that I've entered, one thing is we don't have proper detailing. The ceiling in an air-conditioned space, it has to be properly sealed. No leakage. Because from fixes, warm air will always move from warm to cold place. So whilst we are here is colder than outside. So the air outside will find any available space to come and neutralize the microclimatic that we are creating in this room. And especially our doors, you always see gaps, meaning the heat or the cooling that we are producing is not staying in the room. So instead of the AC, we buy inverter AC. We say, oh, after turning the temperature, it will go off. But since the coolness is not maintained or staying in the room, it will never go off. And we find our AC running throughout the day, and our consumptions are on the high. So proper detailing, air sealing is important when it comes to the building envelope. You are the ones that will do the renewable energy integration. That's where we are going, and your expertise is required. The building automation that we are talking about, buildings, the future buildings will communicate with each other, and that's what we are talking about, net metering and other things. You are the ones who make that possible. So you should know that you have a huge task. You are the one that do the commissioning, and the equipment selection is very important. It's not just about buying 2 stars, 5 stars refrigerators and other things. Depending on your need, you will size your equipment. So we are talking about net zero, but you are the ones who make it possible. So you should know that that's your responsibility. Energy efficiency is not a separate discipline. It's an essential characteristic of excellent engineering. And the best engineering is invisible. As an engineer, your work shouldn't be visible. I should walk into an office and I feel the work of an engineer. Oh, this place was properly designed, the equipment were properly sized, efficiently, reliably, and sustainably. Engineers build more than systems. You build conditions that makes a nation lives in. So as an engineer, you're a nation builder. You have to understand that as well, because you are building the energy security. You are building economic competitiveness. You are building public health. If you design a hospital, you should know that you are influencing the health of people. You are building climate resilience. You are talking about climate resilience. We are the ones ensuring that infrastructure quality. So you build more than a system. The legacy of an engineer. This will not, normally I mentioned that you design a system or even you work somewhere, but it will get to a time, nobody will even remember that you work in a place. But at least people will stay in a building that you help shape to be thermally comfortable, to be efficient. Though they might not know you, but they will experience the good work that you did. And that's the legacy that you leave behind as an engineer. So every calculation as an engineer is a promise, and it's also a vote. It's a vote for efficiency or waste. So when you are designing the mechanical systems, the building services, you should know that you are casting your vote for energy waste or for energy efficiency, for comfort or discomfort, for reliability or failure, for sustainability or depletion, value or cost. So the choice is yours. And normally the politicians put it in the best way that we should vote wisely. So when you are designing your systems or doing your calculations, you do it rightly. So what are we building? And normally people say we make a living by what we get, but we make a life by what we give. So the systems that you are designing, these are the things that you are leaving behind. These are your legacy. You remember the pharaohs, the Caesars, not because of what they acquired for themselves, but what they left behind for the others to come and enjoy. So what are we leaving behind for our children to inherit? And I'm talking like this, not because I'm an energy expert. I'm not talking as a professional to my audience. I'm talking as a Ghanaian to my fellow Ghanaians. I'm talking as a brother, an engineer to my senior engineers. I'm talking as a fellow traveler on this journey that we call Ghana. I'm talking as someone who has looked in the eyes of my children and have asked, what is the future that I want this case to inherit? I don't want my children to stay in Europe and just be enjoying, and when they come here, they want to run away. I have to design the Ghana that they'll be proud to inherit. I have a lecturer in Germany who is living at the age of 50, 60, they are living in their parents' house, their grandparents' house, because those buildings are built as legacies. They are built as fortresses. They take pride in living in even their grandparents' houses or buildings. But in Ghana, if you are 20, even 30 years, and you say, oh, I'm still staying in my parents' house, like what? Yeah, but when you go, they are not even interested in it, because we are not building structures that certifies them. So the legacy we leave behind, history will not remember how many buildings we constructed. It will remember the kind of nation those buildings helped to create. So the future of Ghana is not waiting to be discovered, it's waiting to be engineered. And who are the ones to do that? we are the ones here to design the future of Ghana. So on that note, I'll bring my presentation to a close. And just as Engineer Jay mentioned, this is just to tell you about our intention about the built environment. There are a whole lot of things this is the beginning of the relationship. There are a whole lot of things that we have to rely on you as professionals. And I know you have a great skill set. We don't know it all. There are times that we need you to come or to direct us in certain areas. And our doors are always open. We are relying on your professional skills to succeed in energy efficiency in buildings. So thank you. I will hand over and the floor is open for family discussion. Any concerns, any additions or subtractions? And Engineer Jay mentioned that feel free to criticize. So if you have any of those things, the floor is open.
Okay, so yeah, so if there are questions, we'll take them. But I think we've been sitting for almost an hour plus. Can we just stretch a bit as we prepare to take the questions? We have a second presentation, so we'll get that one also loaded. That one is like a technical working session where we will take snippets of the regulation itself, not the EPC regulation. Sometimes 6 months you haven't gotten your permit. So we are the last people or the last set of people to go and add to that particular delay. So all that we are saying is that when they go out to the field and they are doing the inspection, let's say the EPA, they are checking fire, they are checking the what they call it, they call it the cadastral plan, they are checking and all that. Add another layer of energy efficiency to it. So we are talking about passive design for the residential. So for residential, the compliant pathway is a prescriptive. So you submit, Engineer Ebenezer will give us the details. So if somebody for the residential, that's the prescriptive. When you submit your design, they look at it. So when you look at the cadastral plan, you can tell that no, it looks like they built to face the road. Yeah, online, thank you. Okay, so yes, we have 3 people. So I'll start with Engineer Charles. Engineer Charles, please unmute your microphone and ask your question. Engineer Charles Manakwatan, yeah.
Thank you very much, Chairman. Thank you also for a wonderful presentation and a great way forward for Mother Ghana. And from the presentation, I know we learned that when we pass the design and construction stage, technically we are locked in. There's little we can do to achieve energy efficiency. If you want to try and do, I think it will cost us even more. So my question is, in this regulation, I want to know if specific steps or regulation has been put in place for the buildings, older buildings, or the buildings that we have already. Because I'm asking this because the Energy Commission, you know, the certified wiring practitioners.
Yes.
Before they came, before the regulation, the LI came, there were a lot of people having their own meters and who were not conforming. And nothing was done to bring the the old system at par to the new regulation. So you when you go to field, you see that when we are going to certify an installation of maybe a particular room, but the whole build, the other building, the whole building, the people there are not complying. The systems are not in at par with what we are preaching now, and there's nothing we can do about it. So I want to know the specific steps that are in place to, compel the old building owners to also do something about it so that we can achieve the energy efficiency that we want. I want to give one example. You see, I know that if you have a building, there must be, you have a land, there must be a percentage of the land that you can cover with your building. And then the space left, there must be a percentage that you must leave, let's say, untarred or on concrete, if it's a word, that you do not have to put concrete on.
Yes.
So that we can have, you can plant some trees or, some flowers there to also improve the energy efficiency around the house. I want to know if there are specific steps, because the old buildings, they can comply with these ones. Even though maybe they are finished building, the orientation is bad, the envelope and everything is not working. But as for the space left to achieve these things, I think some specific regulation can compel them to comply. Thank you.
Okay, so thank you, Engineer Charles Omane-Kwati. So the regulation takes care of existing buildings. The EPC regulation that we are actually working on, the energy performance certification for buildings, takes care of existing buildings, but then we'll give them some number of years. We have some moratorium. When it is passed, this is a capital intensive, so the implementation will be, like you said, we are still thinking through to see how many years we should give building owners. And we are doing that particular planning or thinking with professionals. When the law is passed, how many years and all that do you think we should give building owners to comply? So there are 3 compliance pathways. And like you said, in the building code or the building regulation, you are supposed to leave 30%. If my memory says me, 30% should be unencumbered. Nothing should be there. No concrete, no tiles, and all that. It's part of the checklist. So the second presentation will go deeper into that. All those provisions, we have taken them out of we have picked them out of the building regulation, and we are now putting them onto a checklist so that they look out for these things in your plan, even before you start hitting the ground, so that the cost involved, as you rightly pointed out, you will not incur that cost when you start constructing that particular building. So the existing buildings, they fall under another pathway. The building has already been constructed, and so you cannot go and look at the plan. What you are looking at is the performance, if it has been working for some time. So we call it the energy performance certification, where an energy assessor will come in and then check your energy use per square meter per annum. So they will take all your billing details for 2 years. And then, so the building should have been operating for at least 2 years. So they'll take your billing details and then check for a year. And there's a chart. We compare similar buildings in similar climate. So there's a standard. They'll compare whatever you get. So your energy consumption per square meter for a year. If it off, they also have an energy zone. So we compare buildings in similar, energy zones, and then we'll be able to determine the star rating. So that is for existing buildings. All right. And then we also have the those who go the professional certification route. So we have the EDGE, we have the LEED, we have the BREEAM, we have the Green Star. We have so many of them. They are also into energy efficiency. They are also into, the same thing that we are pursuing. So we are not, we are all, we all have the same objective. So if somebody comes with a certification from LEED or EDGE or BREEAM or Green Star and all that, and it is legit, and the building is energy efficient, let's say 60% efficient on energy, 40% efficient on water and all that, we accept it. We only check to see whether it is legit and all that. So all these things, we have taken them into consideration. So Engineer Omane, your concerns are well noted. Okay, so we'll move on to Engineer Michael Dede. Senior, you can unmute and ask your question.
Okay, thank you very much. So during the presentation, I understand that you, once the law comes in, you would want enforcement to cover all the three aspects: domestic buildings, commercial buildings, and all that. My thoughts or suggestion would be that let's make the enforcement progressively in terms of the scope, rather than begin with everything. Reason being that, one, we need to build capacity over time. And if we don't do it that way, what then happens is that immediately you start and we become overwhelmed. Then, like everything else in Ghana, we no longer apply the law anymore. So my suggestion would be that the enlargement of the scope should be progressive. Let's begin first with government itself, government and its agencies in terms of their buildings. Then we go next to corporate buildings. Let's begin with those two, government buildings and corporate buildings, in the sense that these are fewer than individual buildings. If we begin the enforcement from that point, then it shows government's own commitment to the policies and the law. And then it also shows that we are willing to enforce it on corporate organizations. Once we do that over time, say maybe over a 10, 20-year period, then we are ready to begin. We would have built capacities at the local assembly levels and all through the country to ensure that compliance can go down to individual domestic buildings. Already by the building regulations, LI 2465, we already have enough enforcement in there to deal with individual homes. So let's not bother with individual homes at the moment. That will be my suggestion. So that when it comes to the real substance, we'll be dealing with government and corporate buildings to start with. That will build capacity over time and then allow us, when we are ready to go into domestic buildings. That will be my suggestion on this one.
Thank you very much, Senior. Well noted. So we have noted it down, and we will proceed as you have suggested. Okay, so
let me just add one point. Again, the reason why I'm making this suggestion is that if you look at the initial investment in terms of an energy efficient building, it is much more higher, especially if you come to an individual. Yeah. And therefore, when we want to pass on that burden immediately to individuals, we will find the enforcement very difficult and therefore challenging. And therefore, we then throw up our hands in the air, and then nothing happens as usual in Ghana, because we make beautiful laws, but nothing gets enforced.
Yeah. So Engineer, just before the others come in, it was even a part of our strategy that the lowest hanging fruit will be the public, the government and public buildings, and residential was going to be the last space that we enter, because we know the issues there. The issues there, if you are going to face any opposition, it is going to come from the residential side. So we will learn from the public and the government and public buildings. We will do, we will pilot, make sure we commit all the mistakes that will be committed, we correct them. Then later on, we can extend to the residential. So the residential originally was going to be even the last space that we're going to enter. After we have learned our lessons from the government and public structures or buildings, then we extend to the residential. So thank you very much for reinforcing that particular notion. Okay. So is that Engineer KD like my, yeah, the venerable Engineer KD Lai. And let me say this here. He was on my panel when I was writing my engineering exam. Oh boy. My panel was full of killers. Hey, sorry. In quotes. So Engineer KD Lai was the chair. Engineer Pekwena was there. It was a wild panel. And I've forgotten the other two. But all the questions were wild questions. I left the room thinking, I'm not getting it this year. I have to come next year. But God being so good, I was able to pass through. So, Engineer KD Lai, please unmute your microphone and ask your question.
Thank you very much, Engineer Joe Ajay. Now I know what you call me behind my back. Thank you very much. Please, I have a few questions. Should I ask them at a go, or should I wait for the answer to each one before I proceed?
Yes, your questions are usually heavy, so we'll answer them one at a time.
Engineer Joe, I don't know what I've done.
We'll take all your questions and then take our time and answer them.
Okay, thank you very much. I remember in the presentation, it was mentioned that 30% of 30% of the electricity we pay for is wasted. Did you say in our homes or an industry? If you said in our homes, do you have a percentage of what is wasted in industry? If there's a breakdown. Also, the 30% waste in our homes, is it possible to give a breakdown? What I mean is, for out of the 30%, if you take the 30% as 100, how much is lost, is wasted by the fabric of the building, inefficient energy supply, inefficient equipment, etc., etc., etc. That's number one with the subsections. Now, number two, a figure of 1 billion, is it cedis or dollars, was mentioned for the waste? Whatever denomination it is, how was it calculated? I'd like to know how it was calculated. Yes, and now we talk about the energy consumption per year. You indicated that you are going to, there'll be a table to indicate what is green and what is violet and whatever. But I'd like you to note that if an institution or a building has its own renewable energy source, you cannot rate whatever rating you are using. You cannot use the same rating for that as you use for a facility that depends 100% on grid power. If someone is using renewable energy resource generated by himself or herself, I don't see why you guys should make it so much of your business to tell the person how to use what is generated by himself from an inexhaustible source. Chairman, I think I'll stop for now. Thank you.
Okay, thank you. Senior, so I'll take the last question first. Per the module that we are using, the energy assessors course, we take into consideration all the sources of energy coming into the home. And if you are generating your own electricity and all that, yes, it is fine. It is a plus for you and all that. But we want to see the energy use of the building per square meter. So what the module does, or the formula, is this: we aggregate all the amount of energy you have used within the year, and then we divide it by the net floor area of your building. And then so your energy use per annum for the whole year divided by the net floor area of your building. When we divide, what we get, we compare to the standard, we compare to the benchmark, and then you fall somewhere. So even though you are generating your own energy, no problem, it's a plus to you, you may not be paying for it and all that. We want to know how much, if the person were not to be generating his own energy, how much energy would this building be using? So yes, generating your own energy is fine, but we just want to know the energy that that particular building is using per square meter for that particular year. We
Okay.
want to know.
Thank you, sir. How would you calculate that?
Okay, so your bills are there for us to.
And clearly, the RE sources would not be in it anyway.
Yes, so it means that it's already compensated for. If you are using a grid tied system in your house, or you are even whatever off grid and all that, the energy you don't use will not appear on your bill. So it's already compensated for, because what we will rely on will be your bills. We are not using power analyzers to check your consumption for the year. It's virtually not possible. We cannot log your consumption for a whole year and come and retrieve. So we'll rely on your purchases, which corresponds to a certain kilowatt hours that you use within the year. Then, as for your net floor area, the building plan is there to assist us. We just take out unoccupied areas. So, for instance, the lift, if you have a lift, only the lift will occupy only one space at a time. So the remaining 5 are always empty. We take out that particular space. We take out storerooms. You go to storerooms once a while. We take out garages and car parks. Then from there, we'll be able to check, know your net floor area. So we divide all this energy consumed per year by the net floor area, and then we will get your energy. That particular, we call it the SEC, the specific energy consumption, and it is a SEC that we compare to the benchmark, and then we'll get your star rating.
You take the bill,
yes,
and then you use that to calculate the energy per square meter.
Yes.
Okay. If the person is using grid tied, if he's supposed to use 10 units of energy, and he gets 4 from solar, that means what will appear on the bill is 6. It's 6.
He is okay. He generated
the building
4.
should use 10. He generates the 4.
Uh-huh.
It means it is 6 that will appear on the bill.
Yes.
Okay.
Yeah.
Now, if you use that bill to calculate the energy per square meter, it means that person is efficient.
Uh-huh.
Okay.
Yeah.
But then he's getting so much from solar.
Yes.
So you give it a star rating. This building is purple or blue or whatever.
Okay.
Now, let's say, because sometimes in other places that is used as a selling point, even for the building, that our building is energy efficient, so come and live in it. When you come, you don't pay so much. Now, that person who had the solar leaves the building,
and then
he takes away his solar. But the actual usage of the building is the 10.
Yes.
And so that means the building is inefficient.
Okay.
But because you have used the bill,
yeah,
the bill gives it that class that is efficient.
Okay.
So
I get it. So engineer To, on the tool that we use for the calculation, it takes in consideration all the sources. So grade, it can be grade is this. Solar is bringing in this. If you have another source, let's say biomass, whatever. So it takes into consideration all the sources of energy. Yes, so the bill will give us what the grade you imported from the grid. We'll also check if now most of these solar systems, they have the online monitoring system. We'll be able to check how much you generated over a period of time. If it has been online for some time, we'll be able to check. If not, we'll have to find another way. And then, we have a lot of some of these software that we can use, knowing the capacity of your RE plant to be able to check how much you would have generated within the year, and then we use it. But indeed, the SEC tool, or the specific energy consumption tool that we use for the energy assessment, it takes all the sources. Even if you use a diesel generator, I remember when we actually did some practicals when we were taking that course. I was part of the trainer. cost of energy and all that. So you take into consideration all the sources of energy, then you add everything together. So yes, the bill will give you not a realistic figure because instead of, like you said, the 10, it's giving you a 6. But we'll be able to check that the solar give you the 4 because we'll have to add all the energy sources that is feeding the building. Then we'll be able to divide it by the net floor area and then we get the specific energy consumption. Yeah, so Eben will touch on the other two.
I'm sorry.
No,
Theophilus' hand has been up for a while.
I hope it's a follow-up.
No.
Oh? On the other questions, wanted to exhaust them.
So do you still remember the first question?
Yes.
Okay.
He wants to know the $1 billion that we use for importing where we are getting that figure. That also about the 30% areas of the 30%. Is it cooling alone? Is it which one? I mean,
okay.
Yes.
So when I heard the first question, I understood why the engineer used.
So you can see how I suffered.
Yes. And after the first question, I wanted to say, hey, some of us have 2 megabytes memory, so you have to. Okay, so I actually have the information on the 30%, how much goes into mechanical systems, how much goes into the building material and those things. But this information that is hidden somewhere on the computer, so maybe I have to get it for you. But I have a detailed information analysis on it. And even we can go into details into maybe appliances.
Okay, thank you. Now, is the 1 billion how you calculated the 1 billion cedis or dollars or rupees as the amount of energy wasted in our homes?
Okay, Mr. Frimpong, Engineer Frimpong.
Hello.
Please, you can. Hello, we can hear you.
Yes. Thank you very much. And thank you for the presentation, so clear. My question is, with the local artisans, how do you intend to incorporate them into this whole discourse? Because we know significant number of buildings are built by these local artisans. And so I think we should not leave them out. My next question has to do with the education aspect. I think once a time I even came to Energy Commission with a proposal to try to educate the youth, I mean the SHS. So I had to take permission from GES, which never came. So I had to stop the intention on energy efficiency. I see it to be something like a culture. If that culture is not there, we might enforce and later see it not being implemented. Because we know we are Ghanaians, we are blacks, and our way of thinking and other things are different. So if we want to transfer anything here, we have to be very, very careful. Just as one engineer said, let's start with the government of buildings and corporate buildings and try to have a way of educating the public in order to embrace this new normal. Otherwise, we may spend money but will not realize the achievement. Thank you very much. Hello.
Meeting system to energy meters. If you don't have a permit from the MMDAs and you put up your building, you struggle to get an energy meter. So we are trying to tie it to certain things so that, yes, you can get away with this one, but it will come back and hurt you. So we are looking at ways we can actually make sure that some of the things that are happening elsewhere are happening here. Elsewhere, you can't put up a building without a permit. And then you yourself will go and write stop work, produce permit, and then you finish building. Later on, you paint the thing. Then you go that ECG should come and give you amenities. Water should give you a water meter and all that. So we want to tie it to some of these things: water meter, electricity meter, data, and other things, fiber, and all those things. So we are still jojoing. So if there are things that you think can help us, please help us. Yes, all right. But with the residential, definitely they will come on board after we have learned lessons from the public and then the government institutions. All right. Yes, Mr. President wants to speak, so, okay, all right. Presido has spoken, so.
Okay, thank you very much. You mentioned that you have gone to the MMDAs all around the country. I also know that the Energy Commission has trained a number of energy auditors, etc.
Yes.
Where do they plug in? Because when I looked at the institutional framework, I didn't really see. So maybe they are catered for, but the MMDAs could use these people. Thank you.
Yes. So with the energy auditors, we have a plan. Eventually, we are going to bring an So now, when it comes to wiring, and we started with the wiring program, we started in, it was an advice, you certified wiring professionals. Then it came to partial implementation. You can use a certified wiring professional, and if an uncertified person wires for you, you can go and get a certified person to take ownership of it, and then it will still work. Now we are implementing we are doing the full implementation. If you are not a certified wiring professional, you have no business doing wiring in Ghana. And that is what we want to do. Another LI is coming where buildings that are of a certain age, preferably 10 years and above, you have to undergo mandatory energy audit. So you come and then you check the system. You check the wiring system. Now there's a law about the wiring system for public buildings. When the building has been around for 10 years plus, mandatory, you have to call for a wiring professional, a wiring inspector, to come and do the inspection, and then you follow the recommendations. We are silent on that because we want to, build up the numbers, get a critical mass. Then when you start implementation, people will not have the issue of there are not many. They are all in Accra. We don't have some here. We don't have some here. So that is where we are now. Definitely another LI will come, a law will come, making it mandatory for energy audit to be done in this country. And then by that time, we believe we would have trained enough energy audit professionals everywhere so that we'll be able to carry it out smoothly.
Yes, thank you. I was just going to, I was looking at the capacity issues and all those things that we're talking about. First of all, we are here. We're talking to the institution here, and the institution has quite a number of members. We do CPD trainings and all those things. And the first thing that came to my mind is that how can we collaborate to make sure that probably some basic things on these energy efficiency things is on the curriculum the CPD training curriculum of GHIE. And
Okay.
if it's a collaboration between yourselves and our education committee to mount a few of those training programs that will be available as CPDs.
Okay.
For us here in Ghana, and now that our CPT program is also on FIO, the African-wide platform, that means this can also be available internationally, even beyond our borders here on the Africa continent.
Okay.
The second thing which came to mind, especially when the gentleman's response spoke about he trying to get to the educational institutions and things. Again, as GHIE, especially WINE does that a lot, that they go to schools, basic schools and things, and do some orientation on engineering and things like that. And I think we should be able to take these things further, especially when we have the World Engineering Day, when a lot of our people go to schools to go and make orientation and things. Basic information packs or frameworks, if we develop and it's available to our members, when they go out on these outreach programs to schools and things, they should be able to use this basic thing on energy efficiency, energy conservation things, so that when we go out, we are also able to do it. That means we are empowered with basic materials that any intelligent person should be able to use to instruct children or to motivate them. So I think probably these are areas in which, and probably Atu can take it up probably with you to see if, first of all, the mounting of CPD, basic CPD courses that can be on our framework that we can promote and get people to come and do. And number two, this thing about taking the message of energy conservation, because it's a long-term issue you are attacking. And the moment we can go, when I go to church and they call me to speak about something, I can decide to focus on energy efficiency and speak about it.
Yeah.
So these are the sort of things I'm thinking about. Thank you very much.
Thank you, Mr. President. So just to give us some info on some of the things that we do. So we currently have a program where we go to the second cycle institutions and educate them on energy efficiency and conservation issues, just as you are saying. And we have a manual that we have developed with pictures and all that, and any age group. In fact, it was tested with a pupil in class 4. They were able to read and understand. So it has all the gadgets that we regulate. So how to use an iron, how to use microwave, how to use and all that, switch off when you are not, so energy efficiency and energy conservation, all these things are in the book. And we've been doing that for years. So we started with we call them the identifiable consumer groups. So we've been to the Ghana Army, all their barracks across the country. So we've done this energy efficiency sensitization. We went to Ghana Police, all their barracks across the country. We've done fire service. We've gone to, I think, immigration, prisons, Ghana prisons. We've gone to all their barracks and educated them. So now it's the second cycle institutions that we are focusing on. And then also markets and churches, like you said. So it's a laudable call, and I think we need to intensify it. The only thing is that it's a bottomless pit. You need a huge budget to do some of these things because you need to keep it going. You do one or two, the impact cannot really be felt. So thank you very much. We'll keep it up. Collaborate. Okay.
Material for you.
Okay.
And so that means we become partners in
Okay.
so that means the cost comes down, and a lot of this probably will be done on voluntary basis.
Okay.
If you have to go, somebody will have to pay for your TNT and everything. But if I go to talk to my church, it doesn't cost the church anything. It didn't cost you anything.
Okay.
But I become an ambassador because I have available the material that you have at your disposal. So if we collaborate a little bit, probably we can empower our members to become ambassadors for some of these messages, and that's the way I'm thinking about it really. Atu,
yeah, Mr. Frimpong, he has been an integral part of all the outreach programs. So yes.
Yeah, so the materials that you're talking about, we have it on our website, Energy Commission's website. The booklet that he's talking about is self-explanatory. When you pick it up, you can use it at any level. We have it on our website, but we can still provide you with a soft copy. We have QR code that you can scan. So even if we give you just a booklet as an institution, we can scan and then use it at any level. We've been to churches, markets, and other places. We've done regional coordinating councils. In fact, next year we are delving to district assemblies because they have the capacity to, give contracts and other things. So if they don't have this at the background, they can just pick up anything, especially when they are doing their procurement, whatever, they have to incorporate it. That if you want to build, a house or an office, you have to incorporate this as we are, teaching here. So we have the materials online.
And then also, you want the issue will be the hard copies. That's where budget comes in. Printing the hard copies. That's where we will have an issue. So yeah, so we'll just bring a few copies. We'll bring a few copies. I'll liaise with my chairman. Okay. Yeah. Of course. We will still take members through. Yes, we are available. We can. No problem. We are available. We are available. And then, Mr. President, we also do what we call green public. Our procurement system in this country is not. We want to buy AC. Oh, go and bring 3 invoices. Go and bring 3 invoices. Which one? Okay. We buy based on cost, but not on energy efficiency or energy consumption of the appliance. And so we have a team that has been going around. So we visited the hospitals. They are the most guilty hospitals. It's all about price, cost, and all that. So we have been educating them that don't look at the cost, but look at the energy consumption. Yes, it may be cheap, like they say, overturn low, but overturn high. So you buy it cheap, but then it will take all your credit, prepaid credit. So we have all these programs that we are actually rolling out.
So in terms of energy efficiency, I would want to know your take on solar energy and then electricity. Which one would you advise? Thank you.
In terms of
solar energy,
and then, the cost.
Yes. Because I realized that even in your presentation, most of the buildings had solar
panels. Yeah.
Yes.
Okay. So in terms of solar, as for solar, everybody wants solar. It's the initial cost that usually deters people. It's a very good solution. It's a very good way of powering your home and all that. Whenever the lights are off and you alone have light and there's no noise, everybody's like, hey, what is happening? And it's very, very, nice. Very, very, very nice. If you have solar in your house, you testify. It doesn't make noise, it's reliable and all that. But the initial cost is the issue. So yes, if you ask me, if you get a good designer, by a good designer, I mean somebody to come and check your load. It doesn't start with the number of rooms. So when people say, rooms near saying 3 rooms, and no, we don't size solar like that. People are saying it doesn't work because the 3 kilowatt peak, no. You have to size by putting a power analyzer there to check the person's consumption. Then from there, you'll be able to tell the person that you will need 5 kilowatt peak solar PV system with 10 kilowatt hours batteries. So it works. Solar works. The only issue is the initial cost. But with time, you realize that you break even and then everything becomes your profit. All right. Okay, do you still have a hand up? Oh, okay. Senior Engineer Dede.
Thank you very much. I posted my questions, but let me, now that you've called me, let me ask you. Have we considered mini or micro wind turbines for as part of the RE augmentation of buildings? Then the other one is, what are the real capacities we have developed locally to dispose of batteries safely after their lifespan?
Okay, so the first one, mini windmills, eh?
Yes.
Okay, we are still having issues with the wind speeds. They are still not too, viable for commercial windmills. But we've noticed that lately a lot of innovations are coming on board where they are trying to develop some windmills that can still work with some very low wind speeds. But like you said, we are still watching that space to see how we can maximize it. And Ghana, we are not blessed with a lot of wind. We only have some few locations that are promising, Aitepa, and then some places along the Volta coast. Yes. So these are our brightest spots, and even that nobody wants to push his money there because it may not be viable. So we are still watching that space, and we are still trying to see how we can make it work. And the second question had to do with, if you can help me, the second question.
Disposal of batteries. Recycle batteries, yes. Whether we have built capacity in the country, because although the law is there in terms of electrical waste, whether we have actually built capacity to dispose of them, because now that we are promoting more of these storage facilities as a country, we possibly need to be looking at capacity we have developed.
Yeah, so we are actually working with EPA to look at that particular space because we have a lot of e-vehicles coming in and a lot of solar batteries also coming in. Capacity, as of now, we cannot say they actually have have that capacity, but I know that like the politicians say, plans are far advanced to make sure that we don't, Ghana doesn't become a dumping ground for some of these things. Yeah. Okay, so we have one final presentation, and then this one will not take that long, and then from there, we'll break for lunch, and then we can all return to our offices. All right, so over to Eben for the second session.
Okay, thank you, Engineer. Okay, so this is a checklist designed for residential buildings. And just as I mentioned, we don't want to burden this so much. So these are simple requirements that they have to meet. And one is on the site and the orientation. So you want the building to be oriented to minimize solar heat gain. So you have the long axis running from east to west, meaning you have less exposure to the east and the west. And the reason being that due to the direction of the sun, rises from the east to the west and even stays longer at the west. So your exposures, your windows at the east and the west should be minimal, or you should have the shorter side facing the east and the west. So if that's taken into consideration, this will So another thing is permeability or landscape. And nowadays, the way we are replacing everything with concrete, those things, and when it rains, you just have runoff, no water is absorbed. And so we want to also, according to the building code, there's a percentage of the unbuilt site area that has to be kept for greenery and other things. So we want to check whether that's been taken into consideration. And me, for example, I always advise, normally when you are designing your car park, you shouldn't have it at the west side of the building because of how the sun stays longer at the west side. So this is where you can have your greenery so that the heat gain can be absorbed by the soil and the plants that you have on that side. So these are the considerations. If they are taken or if they are observed, you take yes, if not, no. Then the building envelope. So we have window to wall ratio. And what we are saying is, there are prescriptive requirements, but we didn't want it to sound so technical. We can actually quote, maybe it has to be window to wall ratio has to be 15% of the wall or floor area and those things. But we are saying that the east and west grazing should be less than the north and the south, because the north and the south, you don't receive direct sun rays. So if you want to have openings for ventilation and for daylight, that's where you have your grazings. So these are considerations that if it's observed, yes, if not, no. Then external shading, if you are having your windows at the east, have you provided shading for them so that there's no direct sunlight on your windows? So these are some basic things that we want residential buildings to fulfill. Then they are good to go. So roof and envelope design to minimize heat transfer. I mentioned that our roof is a corporate because we have the sun on our roof throughout the day or most part of the day. So we have a lot of heat gains from the roof, and there are strategies to minimize that. We can have reflective roof, we can have ventilated roof, we have cool roof and other things. So has some of these strategies be taken into consideration? And normally we are providing this as part, sometimes the person doing the design doesn't even maybe know, but we want them to be aware of some of these things so that in their designs, they can also be conscious of them. So natural ventilation, at least 15% of the floor area is openable window or vent. So make room for natural ventilation. I mentioned that some of the spaces, once the lights, the electricity goes off, you can't stay in the room. You start sweating. But there should be room for natural ventilation. And every site has a microclimatic condition. There's a direction of the wind in on every side. Normally we say that, we go out and outside is somehow you find the air blowing and you say, I hear that a lot. So how can the air enter your building? Because of how we position our openings. So this has to be taken into consideration. Then daylighting, you also have to take into consideration daylighting. At daytime, I don't even on my lights at home because where the windows are positioned, I receive enough daylight to do everything that I have to do. Electrical design systems, we want it to be done by someone who is certified electrical wiring profession. And I give an example. There's one that I didn't mention. Sometimes where we position our switches, they all even affect energy performance. I was in my hotel room, a very big bed, and slim man, I'm lying just one side, very small side of it. To sleep. But where the switch is positioned, By the time I'm in call abano, no credit every money. So I just have to sleep and leave the light on. So where we position our switches, they all matters. And that's why we also want it to be done by certified electrical professionals, because all these things are being taught as part of their course. And clean cooking, we are moving from the charcoals and the wood fuels. Now we are promoting clean cooking. One, because of the impact on our heads, the smoke and the other things. In Germany, we cook a benquine and beans with the electricity, but it seems you can't try it in Ghana. I'm here to find out the science behind it, because I was cooking a lot, but I had a try anasa. So, but we are promoting clean cooking, and if you're using LPG on your design, you have to see that you've left a space where you can have your cylinder, or you can keep your cylinder and all those things. So these provisions have to be made on the design. Then innovative measures. These are, if you are considering anything beyond these basic requirements, maybe you want to use solar and those things, energy management systems, we consider this as innovative. So that also comes with extra points. Then we have economic efficiency or analysis. Someone mentioned the initial cost being higher and those things. And even there are people promising, someone will say, oh, I want to use 5-star air conditioning, but you don't even know the price of the 5-star. So we want you to have an idea of the systems that you are specifying. Are you aware of the cost and the implication and your net present value, rate of return on investment on those things? Just as we are talking about the initial cost, we want you to know the long-term impact of that decision, because that's a financial decision. If there's a 5-star AC which costs 5,000 and a 3-star AC which costs 3,000, your building will stay in place for 50 years. AC, if it's well maintained, 10 years, 12 years, you can use it. So which ones makes economic sense? Is it the 2-star? Is it the 3-star? You buy it at 3,000, but you pay electricity bill at 100 cedis. Or the 5-star, you buy it at 5,000, and every month you are paying 50 cedis. So we want you to make this calculation so that you are well informed on the decision that you are taking. Okay, madam.
The electrical system design. So are you saying that you want a certified electrical wiring professional to do the installation, or you want the design to be by the
draftsmen, and they sit down somewhere and then they switch they do it. But we want at this stage, you are presenting an application, you want a permit. That particular part, since you cannot let an electrician go and design a structure, beam here and all those stuff. When it comes to the electrical part, we just want somebody with the eyes to do that particular part. They will present that we call the plumbing, EWP, MWP, MEP, mechanical, electrical, and then plumbing. The electrical part, because the electrical is quite dangerous, the building, everything is important, but one particular component can cause fire to everything. So we want that particular part to be looked at by a professional. And how do you know it? Let them append their stamp or something to it so that we know that a professional has taken ownership of that particular part. That's what we are looking at.
Her question really about the CEWP. In your place who a CEWP is. Those are technicians. Those are people who do not actually do design. If you want somebody to do design, you need to get a properly certified engineer. And that's what must be there, because a CEWP does not really do design. He does what he's told to do. So if it's about the process, an inspector. No, they are also not, they are not designers. I mean, they are wiring inspectors. And electrical design goes far beyond just the wire. There's a lot of sizing, transformers, lights, how many lights you need in a room, all that. So when you want to go through the process of an electrical system design, you need to put a certified engineer who can do that.
Okay, so I think that's a good one. So a good input. Thank you very much. And that's why we're here. So
then you would need to
they follow a different path. The residential people, they are following the prescriptive path. So here, it is not usually a huge building. It's not usually a huge building. Yes, the risk is the same and all other things are the same. But at this level, it's usually 1 bedroom, 2 bedroom, 3 bedroom. It's a residential facility, 4, 5, 6, and all that. When it comes to this real estate people, Reggie Manuel and which of them, Aduma and all those people, they are building estates. It is purely residential. But yes, your call is well, is in order. They don't do design. I accept that. They don't do design. Yeah, so thank you. We will, in fact, that's why we are here. You are drawing our attention to so many things. We'll sit back and then even consult you more on some of these issues before we make it a law. So these are all suggestions, they are not cast in concrete.
okay, thank you, engineer. So in all, there are 12 provisions. Each one, if it's yes, is 2. If it's no, 0. If it's partial, 1. Needs major refinement, 0.5. So, and the sum is 24, that's the total max, and the minimum is 18. So the question is, are we fair? 18 over 24. These are basic requirements that as a residential building, you should be able to meet to get your permit and move ahead. So are the provisions achievable? These provisions, are they achievable, or we have to adjust it, massage it more?
I'm very sorry to interrupt, but my hand has been up for a while, and there are gaps in the communication.
Forgive, senior, the 1 billion, we have this thing for you, the source, the $1 billion loss on fuel costs. It's from the World Bank. It's from the World Bank report, Energizing Economic Growth in Ghana. That is where we got the figure from.
Thank you very much.
You may proceed.
First of all, I think there's a problem with internet connection at GHIE. We suffered the same thing yesterday. The times that we don't hear you at all. My question is, my comment is, the scorecard or the scoring sheet which was presented. I'd like you to consider correcting for a few things. Generally, or in some areas, the way the sites are laid out, the long sides are actually east and west. So it could be 60 by 100, 70 by 100. So you cannot have, it's almost impossible to have more windows on the north and south than the east and west, because the north and south are usually, not usually, in some cases, maybe 50% of the time, the north and south are usually shorter than the east and west because of the way the site is laid out. It has nothing to do with the owner of the plot. It has everything to do with the local government. So when you must have to look at the parameters which went into awarding marks for where you have more windows or less windows. That's very important because the householder can't do much about that. And daylighting as well. Daylighting is very good, but we must realize that daylighting cannot penetrate when it's a deep building. I mean, no matter how you do it, unless you introduce reflectors, etc., which could be very costly, and environment, they'll be dusty in no time. You spend so much money on maintaining them. So daylighting is good. When you are asking for or awarding marks for daylighting, we should be mindful of the fact that it cannot penetrate. Usually, there's a percentage which I can't remember. It cannot penetrate beyond a certain percentage if you have a deep building. So those are the 2 points I want you to consider when you are revising or trying to have a second look at your marking scheme. For now, thank you.
Okay, so thank you, sir. And on the first one, that's why it's important that we have to collaborate, because that even tells us that the one doing the sites, which was as saying.
The other thing, please, we don't all speak tree. So if you could stick to English, that would help us a lot.
Yeah. Yeah, so the surveyors are important. The person designing even the roads in the area is important, because normally we build to face the roads. So that's the need for the collaboration that we have to push for. And on the orientation, that's why we also have shading in there. So in case maybe the windows have to be on the east and the west, at least provide shading for that. But thank you very much for the concern.
And also,
Okay.
please remember the daylighting bit as well. Thank you.
Yes, please. Engineer Enoch Japan. Oh, hands down. Please, can you go ahead or okay, control room. I think we can go back to the slides. Because of the Zoom, okay. Yeah, it's working now. Yes. Okay. So are the provisions achievable? Daylighting, electrical systems, I think the concerns has been raised already. So should we create another document on energy performance or energy efficiency report, or this is something that can be incorporated in the mechanical or the electrical, yes, the electrical or the mechanical document, or there should be a separate document just on energy efficiency? Or it should be integrated?
Sorry, you haven't called me, but since you're asking a question, you said an architectural drawings. So that's a problem with engineers. The architectural drawings have nothing to do with the engineering. So we have to say all drawings. It should be architectural and engineering drawings.
Okay.
Architecture, and sometimes in Ghana, when you say engineering, people think it's only structural engineering.
Okay.
So architectural, structural, and building services drawings.
Okay. So I think the building services can house or can take.
It doesn't take care of structural. So architectural and building services drawings.
Okay.
Yeah. I don't know whether how important structural will be at this stage because of what we are looking at energy efficiency. Because we're not talking about the construction process, so I don't think structural would be very important for us. I don't know. That's my opinion. So I would say architectural and building services drawings. Thank you.
The first table, the checklist that you showed us. Then after you went to the table, this table. No, the table that has the, because my earlier understanding was that the checklist was just for residential buildings. It's just for residential buildings. But here we are being asked building an energy efficiency checklist. Is it also commercial buildings, public institutions, and the like? Because you see, when you move into bigger buildings, it's a different ballgame. You know, you can't just use a checklist. There is a sustainability report that sometimes is done before even the building is fully designed. You know, like how the geotech people do their reports, like how the traffic impact assessment. There's a sustainability report that is done for a big building, which is also at that point, you know, brought in for those to assess what is inside. You know, as part of the permitting process for the they have something that they call AIP, approval in principle, which is done by the MMDAs. At that function, all the impact assessment reports that they brought is brought for assessment and review by a panel. And as an institution, we always send reps. But because we don't have something on energy efficiency electrical, it's the geotech people and the traffic people who go there. This morning, for instance, we had a team that went to Ayawaso West for a building project that's been done. But it's only geotech and traffic. To assess what has been done as part of the design. So we can't just have a checklist that goes across for all kinds of buildings. A checklist is okay for a domestic building. And even that one is just a 2-bedroom, 3-bedroom. The kind of buildings people are doing nowadays. You can't just do a checklist.
And that's the whole idea. For the bigger spaces, office, we expect them to do the certification. We expect them to go the certification route. So an office complex and all those ones, no. The edge, all those stuff. So they go into details because they have the money to spend. So they will not even be struggling with orientation issues and all that. They have professionals who actually do their planning and other things for them. So you are spot on.
Okay. Yeah, now so okay. So thank you, engineer. So another thing is we want to introduce energy performance assessors, and we know the design has to be done by a team. So an architect, maybe energy designer, someone doing the mechanical structure and those things. So we the modeling, the simulation, and those things. And the question is that going to create a bottleneck, or is something that's in order? Adding another skill set to the team, energy performance assessor, to do the energy or to handle the energy simulation and the other things, to do the energy design and the others.
As I mentioned, in practice now, we have edge consultants, edge people who have been trained by the IFC, who are edge certified, who sometimes when the as part of the team to come and do an assessment for edge. So they are usually separate from the design team, but then they are also part of those. So they assess, because, you know, from energy efficiency, as we've said, it's not only from electrical angle or from mechanical, but it's the whole team, the architects, the choices they are making, insulation, windows, and all that. So all that information is given to the edge assessor. Then he assesses what grade must be given to the building. So for that, we may need to have an assessor who is separate from the design team to assess all the energy efficiency measures that have been done in the building.
Okay, thank you. So that's the idea, to have someone to handle the energy as well. So we were just independent assessors, or is something that the engineers can handle by themselves. So another thing is the tools to use for the modeling and the simulation. You know, you are familiar with most of these tools. Should we leverage the already existing ones, which is well known, or do we customize ours? So should we use the design builder, the Energy Plus by us, the Open Studio and those things? Should we use the already existing ones, or we should design our own to do the modeling and the simulation and the others, and also to rate the buildings? So suggestions, the online participants, you can also come in. And if you have preferences, because since you've used them, maybe you know the one that will serve us better. So you can come in with those feedback as well. So the issues of draftsmen, and someone mentioned that, and normally when you go to the assemblies, there's something that they will tell you, that even 90% of the designs that come to the assembly is done by draftsmen. So there's an issue, and this is something we all have to find solution to it. We also have unpermitted buildings, and one of our promise to the assembly is that most of the people building, they don't even know that they need a development permit. So they just start constructing their buildings. So as part of that, we are going to raise awareness and those things. And you can see this drawing, and this is not just my sketch. This is actually my neighbor. So I went to my site, and the first floor has been built. It's a story building, and this is what he's building with. And this is the architectural drawing that he's building with. And I became more concerned. He was talking to the contractor. So when I saw the structure, and I said, this guy, if I don't approach him, later it will be a problem to me. So he was talking to the contractor, and the discussion was the only window to a kitchen only goes to the hall. No, a kitchen doesn't have an outside window. So how do you design a building like that? And so these are what people are building with. So you can see that there are challenges at the AMDAs, and we all have to find solution to it. And as part of it, what we can do as Energy Commission is also to create awareness that if you are building or you are starting your construction, you need a permit, and also the requirements will be there. So if you are redesigning Ghana's permit system today, what will you change? So if you have any additions, or if there are some bottlenecks that has to be considered, you come in with that. So I think that ends these sessions as well. So the feedbacks, all the things, the questions that you noted down, you can kindly come in with those questions. I have technical teams here. My technical team is here to assist.
Yeah, so because of time, we will take the feedback electronically. I'm a member of this house, I'm a member of GHI, so I'll leave my details with DMS, Director of Medical Services, Membership Service. Yeah, so let me give Director the final word on this, or my chairman, your final word. We spent too much time here today.
Okay, thank you very much for the time that you've spent with us today. I think at some point, the speaker was saying that as we begin this relationship or something when he was speaking, but I think it has to be emphasized that it is an ongoing relationship. It's an ongoing engagement. I basically see it as a build-up onto all the programs that you have been running, the CWP, the energy auditors, thing that we've been working on, and then even the wiring code, because all this feeds also into the wiring code. Because if you are designing a building and you don't do it according to standard, you get a lot of overheating in the building, and the overheating is a result of energy being wasted. If you are in the house and your floor is getting warm and the place, it just means energy that is going waste, because it's not going through the wires as it should. If your wires are too hot, it means that it's energy, there's too much friction, and it's causing heat, which is causing it to be wasted. So it is all that we've been doing over the years, the wiring code, CWP, energy auditors, it's all a build-up. And this is the next stage that it needs to feed into. So as we said, we've been with you. It's part of the process. We are always there. We will continue to give our technical inputs. This, as you said, is where to ensure that it's made something that is workable. So on that note, thank you all so much for coming. from the commission and then from the institution. Our members who join on the platform, it's a Thursday afternoon, 11 o'clock. Our people are usually not available, but it was good to see that at least we had 50 people join, 80 at some point, join at some stage. So it shows the interest that we have in this thing, because we believe that it will also formalize the process. One of the things that I may need to add is that, you know, in the permitting process, we have to submit a set of drawings. What is usually asked for by the MMDs is the architectural, structural, but not so much emphasis is put on the MEP, electrical, the plumbing, even air conditioning is usually not asked for. But as we get into this process, we must tell them to get a full submission of certified stamped drawings by the right people. Every drawing that must go must be stamped, and they must ask for the full set of MEP drawings, because that's what will inform the energy efficiency process. Because if the choice is not made at that stage, it will go through the system and then it will just create problems down the lane. So thank you very much for coming. We spent so much time, but hopefully when we are invited for another session, you will join us again. Thank you so much. So we'll take a group picture in front. So all those who have been with us, you can join in front. So we'll take a picture.
Okay, so those online, don't leave us yet. If you can put on your cameras. We want to capture you. We want to capture you, yes. Yes. Senior KDL original.
John, you're on my case today, John.
If you can capture them. Yeah. And then the rest of us, can we? Yes, they will be in the background. We'll be here. Can we all come? And when we are done, don't forget to pick up your lunch on your way out. Yes. Please come.
Engineer Lai, smile a bit. Why?
Hey, Dr. Edie. I can't see my face, so I didn't know I wasn't smiling.
You were born before computer, like me.
25. Oh, I was born long before you, my friend. Don't promote yourself.
Yeah.
I was born long before you. Don't promote yourself, Edie.
Accept.
Very good. That's all. No argument.
Michael is growing a beard. He wants to be old like you.
Don't mind him. Maybe the beard is even fictitious. Are we finished with this picture so I can rest my facial muscles?
So that we can disappear.
Exactly.
I'm sure they've taken the pictures already.
All right. So thank you, everybody.
Thank you.
And we should meet. Now that you are around, we should meet sometime, Charlie.
You have my number. You are my boss. You give me a call. We'll meet.